So we have 8 equations. Okay, so now if I substitute m0 is equal to x0 minus x7, m1 is equal to x3 minus x4, m2 equal to x1 minus x6, p0 is equal to x0 plus x7, p1 equal to x3 plus x4, and p2 equal to x1 plus 6. m3 is equal to x2 minus x5, and p3 is equal to x2 plus x5. m10 is equal to p0 minus p1, m11 equal to p2 minus p3, p10 is equal to p0 plus p1, p11 is equal to p2 plus p3, m100 is equal to p10 minus p11, and p100 is equal to p10 plus p11. Okay, so using this defined term, this equation can be rewritten in the form x1 is equal to m0c1 plus m1c7 plus m2c3 plus m3c5. Okay, so this is x1, so this is m0 c1 m0 plus c7, this is m1, this is m2, so c3 m2, and this is m3. Similarly, x3 is c3 m0 minus c5, this is m1 minus c7, this is m2, and this is m3. So likewise, all the equation can be defined in the terms of m0, m1, p0, p1 likewise. Okay, so x3 is m0 c3 minus m1 c5 minus m2 c7 minus m3 c1. x5 can be written as m0 c5 plus m1 c3 minus m2 c1 plus m3 c7, and x7 is m0 c7 minus m1 c1 minus m2 c5 plus m3 c3. x2 can be written as m10 c2 plus m11 c6. Okay, and x6 is equal to m10 c6 minus m11 c2. x4 is equal to m100 c4, and x0 is equal to p100 c4. Okay, so this equation is rewritten these equations are rewritten in some different form. Okay, so using this equation now we can derive an architecture. So in the first level we will calculate pi and mi. Okay, so p0 is equal to x0 plus x7 and m0 is x0 minus x7. Okay, and m1 is difference of x3 x4, p1 is sum of x3 x4, m2 is difference of x1 x6, p2 is difference of sum of x1 x6, m3 is difference of x2 x5, p3 is sum of x2 and x5. So using the variable x1 to x0 to x7, we will first derive their difference, pairwise difference and pairwise sum. Okay, so x0 and x7, their sum is p0 and their difference is m0. Okay, so this is minus x0 minus x7, this is m0, so this is m0, this is p0. Okay, likewise we can generate p1 and m1. So p1 is x3 plus x4, so x3 and x4, so this is p1, and m1 is x3 minus x4, so this is minus, this is m1. Then p2 and m2 in the same manner, using x1 and x6, x1 and x6, so this is p2 and this is m2, this will be minus, and finally p3 and m3 using x2 and x5, x2 and x5, x2 plus x5 gives p3 and x2 minus x5 gives m3. So this is a kind of a butterfly architecture. Okay, so now suppose using this we want to generate x1. So x1 is m0 c1, m1 c7, m2 c3 and m3 c5. So first we have to add this two term, then we will add this two term, and then we will add their result. Okay, because we are using a two input adder. So m0 c1 and m1 c7, so this is m0, let it be multiplied with C1 and it will be given to adder, and M1 C7, this is M1, this will be given to the same adder but multiplied by C7. Before giving to the adder, we will multiply it by C7. So this is a node M1. From this point onward, this will be multiplied with C7. Okay, and similarly we will add M2 C3 and M3 C5. So M2 multiplied by C3 given to the adder, and M3 multiplied by C5, and finally adding their result. So this is x1. Okay, now let's generate x2. Okay, so x2 is m10 c2 and m11 c6. So x2 is p0, m10 is p0 minus p1, p0 minus p1 c2 plus m11 is p2 plus p3, sorry, m11 is p2 minus p3 plus p2 minus p3 c6. Okay, so p0 minus p1, this is p0 and this is p1. Yes, I will use a different color. p0 and p1. Okay, so this will be minus, and next is p2 minus p3. So this is p2, so this is p2 minus p3 minus operation. Okay, so p0 minus p1 multiplied by c2 and p2 minus p3 multiplied by c6, and finally adding them. This is x2. So likewise you can generate all the values of capital X, that is x0 to x7. Okay, so this will be the circuit level implementation of this equations. So total number of multiplications can be easily calculated from this structure. So total number of multiplications are this multiplication by the coefficient C4, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, total multiplications in this structure is 22. Okay, so from 64 we have reduced the total number of multiplications to 22.